So now we have our setup. It's here, and what we're actually going to do, we're going to just get rid of all of this, and we're going to start anew. So I'm just going to make a new scene, and within the new scene, we're going to emit some particles, and I'm going to emit them from a sphere. The reason I'm liking a sphere, actually, you know what? Instead, let's emit from a null, and we can emit from a sphere later. Create basic emission. And the reason why I would pick a null over a sphere, or vice versa, the null is 1 point, and you get to see we have this spread, but the sphere will come out from all different angles. The null, since it is coming from 1 point, is a little more controlled. And then here we'll grab our geometry. And I'm just picking a cube because we're able to get a volume with not there being a lot of points in place. And we need to make sure we freeze our transforms here. So we have these two elements. Now what we're going to use an ice tree on our particles themselves. Since this is what we want to control, we're going to put our ice tree on here. So we'll grab this, and we'll update our ice tree. I'm just going to get rid of the simulation root. So we'll just plug that into here, just delete the simulation root. Make sure our simulate particles are in place. And let's add a few ports. Oops. Okay, so we have a few ports to work with. Simulate particles in place. And then now let's, we'll have to expose one node. We just use basic vector subtraction in order to get the point, for all the points on the geometry in order to know the closest location, or the location on the one object. Since we're working with volumes and geometry here, it's not going to be as easy. It's just an extra step, really. We're going to need to use ray tracing in order to, for these points to know what the closest points are within the system. So in that case, we're going to get closest, and we can either get closest location or location on geometry. If we do closest location on geometry, it will be a little easier. So this node accepts an input and is looking for a geometry. So we'll just drag the cube down into here. So now this is now valid. And this is, if we jump into it, you can see it is using closest location already in it. So it's just less work for us. And it already spits out the most common things you'll need: location, position, and normal. So with this, we have the closest location, and it's using all of the particles as inputs. So every particle will know the closest location on here, and it will spit out the position if we're looking for position. So let's get a set data. We'll grab a set data node and just jam that in here, and we'll grab a self.foo, just a custom attribute, and we'll visualize that. Show values, and we'll look at vectors. So we'll hit play, and nothing's happening yet, and the reason that is, if we bring these closer here and hit play, you got to see when they get within a certain distance, they spit out the location. Let's give us more time. So when they get within a certain distance, then the node begins to work. So that's something to be aware of with the get closest location on geometry. It has a cutoff distance, and by default it's set to 1. This helps with performance, but I'm just going to go ahead and turn this off. We shouldn't really have to worry too much about performance right now. So right now we're getting a location on the geometry. Yay! So that's good. That's exactly what we need. And the reason these are off, again, is because this isn't zeroed out. But we should be okay now. So we hit play, and then this is what we have. Okay, so this might be easier to visualize because right now we're looking at we're looking at the output here as vectors. It might be easier to look at these as points, because this is how we should be thinking about it. So right now we're projecting essentially these particles onto the surface. Not really, that's an awful way to look at it, but each particle knows what the closest point on the surface is, and that's essentially what we're grabbing. So right now each particle is, if we were to make a force out of this, this is the position that they're going to want to aim to, really. So we'll end this one here. This is the get closest location on geometry, and then from here we'll build the force.